So in this video we're going to look at how you compare three different numbers using ratio. The situation I have on the screen here is that I've got three different coloured sweets, three jars of sweets. There are 24 red sweets in the first jar, 36 blue sweets in the second jar, and 66 green sweets in the third jar. And I haven't drawn the individual sweets, I've just sort of set it up like that. Look what happens if I compare any two of them and then simplify the ratio. So if I compared the red with the blue, that's 24 to 36, I could simplify that because both of these factors contain factors of 12, so I can divide both sides by 12, and that ratio simplifies 2 to 3. If I compare, say, the blue and the greens, this ratio also simplifies because these are both in the 6 times table. I can divide them both by 6. And similarly, I could compare just the red with the green, and when you do that, you can simplify the ratio again because, once again, they're both in the 6 times table, so you could divide that by 6, divide that by 6, so 4 to 11 is the simplified ratio of red to green. I could even look at the ratio of all three, red to blue to green, and they still have a factor of 6, so you could divide through by 6. It's not always 6, it depends on the question. But the point is, when you compare any two of them, or even comparing all three of them, you could actually simplify the ratio, and we'd be left with things like 2 to 3 or 4, 6, 11. And so on. Now, I want you to consider a variation on this, where I'm not going to tell you how many sweets are in each jar. So it's a complete mystery how many reds there are, how many blues there are, and how many greens. So we don't know how many sweets are in each jar. However, I do tell you that if you take the number of red sweets and the number of blue sweets and you simplify that ratio, you get 2 to 3. And I tell you that if you simplify the ratio blue to green, you get 6 to 11. Now, I've absolutely no idea how many red sweets there are, how many blue sweets there are, how many greens there are, but I am going to give you that the simplified ratio of those two pairs are 2 to 3 and 6 to 11. That's actually enough information to work out what the ratio of red to green is. Now, if you could sort of work this backwards and you could sort of work out how many reds there are, then of course you could work it out. But we have no way of knowing exactly how many reds there are and how many blues and greens from this particular setup. So I'll show you how we do it. So this is basically the setup that we've got. I tell you the ratio of red to blue simplifies to 2 to 3, not what it originally is, but it simplifies to 2 to 3. I tell you the ratio of blue to green simplifies to 6 to 11, and I want to work out what is the ratio red to green. Now, the way you do it is you think of, first of all, which thing is in common. Now, in this particular setup, and in the vast majority of the questions, it's sort of the one in the middle that's in common. It's the blue that's in common. There's red to blue, blue to green, so blue is in both of these ratios. So I need this blue number to be the same, basically. And then I think about my 3 times table and my 6 times table. I'm trying to find a common multiple for 3 and 6. It's a bit like if you were adding thirds to sixths, then what common denominator would you use? Hopefully you can see I can make them both 6. Okay, 6 is the lowest common multiple of 3 and 6. So if I double this ratio here, that gives me red to blue could be written as 4 to 6. This is already a 6, so there we are. I've done it. I've got that the blue is 6 parts in both, and now it's directly comparable. Now that the blue is worth 6 parts in both ratios, then I can compare the red and the green directly, and that would be 4 to 11. That wasn't the only way of doing it. I could have chosen a different common multiple and it still would have come out eventually. So suppose I particularly wanted the blues to be 12 parts. I could have made that 12 if I multiplied by 4, so that would give me 8 to 12. I could double this one to give me 12 to 22, and that would have told me then that red to green is 8 to 22, but of course that would have just simplified straight to 4 to 11 anyway. So if you use the lowest common multiple, you're probably going to get the ratio in its simplest form anyway. So that was the method. We were given the simplified ratio of this pair, red to blue, the simplified ratio of this pair, blue to green, but that was enough information to work out the simplified ratio, red to green. What we had to do is make the common thing the same number. I'm going to show you a few more examples. And so the examples are going to be, what if we had this setup originally. So the simplified ratio red to blue is 5 to 12, and the simplified ratio of blue to green is 8 to 7. I'm going to show you the answer in a minute, but I'll let you scribble those numbers down in case you'd like to have a go at it yourself. And I'll also do the example where the original setup is, 2 to 9 and 2 to 5. Okay, they are the ones I will do for you in a moment. So this was the original one. So this was the original one we had. I'm going to do this one, where it's 2 to 9 and 2 to 5. And I'm also going to do this one, where it's 5 to 12 and 8 to 7. If you want to pause the video and have a go, do so now, but the solutions are coming up. So for this situation where it was 2 to 9 and 2 to 5, the thing that's in common is blue. So once again, I need these to be the same number. I think this time I'll make them both 18. So to get, because if I'm adding ninths to halves, let's say, I'd be using a denominator of 18. 18 is the lowest common multiple for 9 and 2. So I can make this 18 if I times both sides by 2. And I can make this one 18 if I multiply both sides by 9. So 9 times 5 is 45. So I've made them both 18. Now I can directly compare the red with the green, so that's 4 and 45. Like so. In the same kind of way, suppose my original setup had been that I had red to blue is 5 to 12, and then blue to green is 8 to 7. I need a common multiple. Once again, it's the blue that's in common, so I need to make the blue the same number in both before I can compare the red and the green. Common multiple 12 and 8, how about 24? Okay, 24 is the lowest common multiple, so we could use that. So 24, I'll double this one to get it to be 24. And I will multiply this one by 3. And now I can directly compare red to green. That is 10 parts to 21 parts. And that doesn't simplify anymore, so that's completely finished. I'll show you another example that doesn't involve sweets. Okay, so this time it's about 3 ingredients that's needed to make crumble. It involves flour, butter, sugar, and I tell you like how much butter you need for a certain amount of flour, or how much sugar you need for a certain amount of butter. And then so there's 2 pairs of the 3 ingredients, right? But then I ask you for sugar and flour, how they're connected. I'll give you a chance to read it, have a think about it. You can pause the video if you like, have a go at it, but the solution is coming up now. Now this is the information that's given, that when I'm using 60 grams of flour, I need 30 grams of butter. If I'm using 25 grams of butter, I need 75 grams of sugar. And that we're actually told you're using 20 of flour. So that's got to be a 20 eventually, and I want to know how much sugar. There's quite a lot of different ways of doing this, so if your solution is not exactly the same as mine, that's fine, as long as we agree on the answer. Now, once again, the thing that's in common is B. This time B doesn't mean blue, it means butter, so the butter is in common. Now, you could, if you wanted to, make a common multiple for the 30 and the 25. So think of a number that's in the 30 times table and the 25 times table. Something like 150 fits the bill, so you could make these both 150, and here you multiply by 5, so flour is 300, blah, 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 blah. However, I'm going to simplify these ratios first, because actually these simplify really neatly, and then I can work with smaller numbers. So go ahead and feel free to make them both 150, and it'll come out fine, but I'm going to simplify this first. Notice that 60 to 30 can actually simplify very simply to 2 to 1, and 25 to 75 is 1 to 3. Now, that didn't necessarily, that wasn't guaranteed to give me the same number. Once I'd simplified the ratios, I might need to make them worse again to get the butter to be the same, but actually the butter is 1 part in both, which is great. So because the butter is the same number in both, I can directly compare now the flour with the sugar, so that's 2 to 3. And the question was saying, what if this is 20? Well, I hope you can see that the scale factor therefore is just 10. So if you're using 20 of flour, you'll need 30 grams of sugar. You can use lots of different methods to solve that problem, but as long as we agree that the answer is 30 grams of sugar, then I don't mind what method you choose to use. Okay, and finally for this particular skill, I'd like you to have a go at these 4 questions, please. So you might want to pause the video at this stage, have a go, and then some solutions are coming up any moment. solution to the first one should look something like this. It doesn't need to be exactly like that, you might have used a different multiple, but the final answer, A to C, is 6 to 5. And these are the last few solutions. Forgive the not very high-tech approach. For this second one, I've used a common multiple, where B is 6 in both of them, so you get a final answer C to, notice not A to C, it's C to A, so 15 to 1, not 1 to 5. It's 15 to 1, not 1 to 15. For this one, I've used a common multiple where Y is the thing that's in common. I've made that 27, so you get X to Z is eventually 12 to 5. Via 24 to 10. It still simplifies even though we use the lowest common multiple. And for the very last one, notice that it's not the middle thing that's in common. Actually, P is the thing that's in common. All right, so over here P is 5 parts and over here P is 1 part. I've rewritten it like this where they're written underneath each other. So I've made the P 5 parts in both. You could use a different common multiple, but I made the P 5 parts in both. And now that P is the same in both, I can directly compare the Q and the R. Q is 2 when R is 50, so it's 2 to 50, and that simplifies to 1 to 25.